Java database connectivity. Computer scientists have been using relational databases since the early 70s as they have proven to be the most efficient and easiest form of storing and working with large sets of data, particularly when we need to frequently interface with that data by adding, removing, and editing it. With relational databases, data is stored in tables consisting of columns of data fields and rows of actual data elements. Very much like what you would think of in a spreadsheet, where you may have column headings that refer to what kind of data is in that column, and then each row has sets of information that correspond to each of those headers. The data fields store specific data types, very much like variables in a Java program that you're used to in your development up to this point. Each row of data contains data corresponding to the set of fields defined in the columns. In most tables, one field is designated as a unique identifier of that row, called a primary key. That primary key allows each row to be identified apart from all other rows, so that in searches or in sorting, we are able to identify that single row from all other rows. Relationships between the data in different tables use links to those primary keys, and we call those foreign keys. Because these explanations may seem difficult just using words, let's look at an example of what a set of data tables in a relational database looks like. In this sample database in MySQL, we see we have a table called country. This table has 3 columns. The first column is called country ID, which is an integer, and it is a unique identifier of each country, so that we don't have to rely on the names to be unique from country to country, which you could imagine, if the database were storing people instead of countries, could get extremely difficult. There may be several people named John Smith or Robert Powell in any given database, so name tends not to be a very good primary key. There's also a last update to the record, which is of type timestamp. Now you'll notice that the data types here are different than what you may be used to in Java, and that's typical of a lot of different systems that you may work with. Between multiple programming languages, your primitive or data types may differ some, and when we're dealing with data in databases, there often are different needs in those places as well. So we see that we have a small int, a varchar or variable length character string, and a timestamp here. We won't go in depth into these data types. I do encourage all programming students to take a SQL or database programming class before they graduate, as interfacing with databases and being able to program against them is an extremely important and valuable skill set to have out in the working world. What's important for me to show here is that within the country table, this ID is our primary key. That's the designation that you see where it says PK next to country ID. The most common type of primary key used in relational databases is an auto-incrementing integer. We usually call these identifiers, and these individual identifiers increment with every new row of data. So if a new country were to be created by the United Nations, then we might need to add a row into this database, and it would automatically receive the next highest integer as its country ID. That way, we guarantee the uniqueness of that primary key among all other rows. When a row is deleted, for instance, if a country merged with another country and therefore no longer existed, and we wanted to remove it from our data set, then we would not be able to reuse that identifier. In order to maintain the best data integrity, we do not reuse values from primary keys that have been used even when deleted. They just would appear as gaps within the data set if you retrieved the entire data set. If we look now at this table called city, it similarly has an identifier, an auto-incrementing integer primary key that goes with each city. And those primary keys are unique across cities worldwide. For instance, if the city of Las Vegas had a primary key value of 10, the city of Berlin in Germany would not have, could not have a value of 10 for its unique identifier. It would have to be something other than that. It's these identifiers are unique across the entire data set, not just by subsets. That's an important consideration to keep in mind as you look at data in these various tables. In the city table, we also have this country ID, which is indicated with an FK. That is our foreign key. The foreign key corresponds to the unique country ID in the country table. That relationship is shown by this arrow pointing from city towards country. The foreign key country ID in city corresponds to the primary key country ID in the country table. By setting up this relationship, we link cities to specific countries. If I go back to the example of, say, Las Vegas, which might have a city ID of 10, the country ID might list 22. 22 would then correspond to some country in the country table with the primary key 22, which is unique among all rows in the country table. And in this case, that would be, say, the United States. These concepts will become a little clearer as we program against a database in our example today. But let's go back to our PowerPoint and continue our conversation. Some other things that you would learn about relational databases if you were to take a database programming or SQL class would be optimizations of databases. We can set up special structures called indexes against our tables that utilize intrinsic patterns or order within the data sets so that searches against that data are much quicker and more efficient. We also perform normalization techniques against data designs. The way that we break data out into tables uh, can be done in a very scientific manner using normalization so that we don't duplicate data or set up difficult to manage data sets. We're not going to be going over those concepts today, but again, I do encourage you to take a database class so that you can learn those concepts and understand how they help us when we set up data sets to work against within a given application. There's also database programming where we can create queries against the data sets and we can store those queries for frequently used um, queries against our data or particularly complex operations against our data. And we can store those in things called views and stored procedures. Again, these are things you would learn in a database class, but I'm just making you familiar with some of the things that may be at your disposal in working with databases. In today's lecture, we are going to primarily focus on interfacing with databases from a standard programming language, in this case, Java. The concepts that we use in interfacing with databases are common across most programming languages. In my experience, the items described here are used across most programming languages that are in use today. The first thing we need is a relational database management system driver. We need something that acts as a translator between the programming language itself and the objects we create in that programming language and the database system. So our drivers, which you generally get from the vendor of the database that you will be using. I have created a link to the driver you need with MySQL on the useful links page of the Canvas course shell. So you can look there in order to find the driver that you need to um, do work with MySQL like we're going to do in our example today. Inside of each program, we create a connection string. The connection string defines the database within the database system that we are connecting to. Generally, a database system or database server will have various databases, and we use our connection string to choose which server and which database we are going to be connecting to in order to work with our data. Then we generally have command objects The command objects are set up and populated with strings of SQL code that allow us to do the standard database operations of inserting new data, selecting rows of data that are already in the database, updating or changing values of certain columns within rows of data, and deleting data within the database. We use standard strings to create that code and assign them to the command object. Stored procedures and views can be called in this way frequently, and that is one way to utilize the efficiencies created by the database developer for you. Finally, when we retrieve or select data out of our database, generally we will be receiving several rows of data, sometimes even dozens, hundreds, or thousands of rows of data, and those are stored in data structures called record sets, which contain one record per row of data, and we can loop through that just like we would with any other data structure. To see how this works specifically in Java, let's go ahead and do an example. We're going to do today's example as a command line style program, much like we would have done before we started working with JavaFX. I'm doing this in order to stay focused on the JDBC concepts rather than get bogged down in looking at large sets of interface code for JavaFX. So I'm going to create a program, public class cities of the world. This is going to be a program that works against a specific database that is included for free with the MySQL relational database program that you can download for free from Oracle. To see to see a little bit about that database, I'm going to connect to it. I'm going to connect to the local instance, the version of MySQL attached to my computer here. And what we're going to see here is there's a database called World. That database has three tables: city, country, and country language. We can see by expanding city and looking at its columns that there's an ID, a name, a code, a district, and a population that go with each city. Let's look using a simple database query that I've pre-written over here on the right, where we select the database that we will use. Then we use a select command to read data from that table. The asterisk or star is a wildcard, meaning all columns. When we want to select every column from a particular table, it's quicker and simpler to say select star from the particular table. A where clause added on to our query specifically allows us to restrict what data is returned. In this case, we are going to return data where the district is Nevada. they're using the term district in a sense of, say, a state in the United States or a province in Canada. Different countries have different names for the geographical districts within that country, so they selected the term district in order to make it fairly universal. One thing that is important to note, and you may even have already noticed it um, when looking at what's listed over here in terms of columns, database names, etc., and what I have over here, SQL is not case sensitive like Java is. So frequently for quick queries, programmers won't generally take a lot of care in how they format their queries, using mostly lowercase simply because it prevents the need from holding down the shift key. There are conventions that are frequently used with queries when we write them for use in views and stored procedures, or if we're going to save them off to a disk and share them with others, where we frequently put commands, which are the color-coded keywords here, in all caps, and then match the capitalization of the actual database table and column names with what the database designer did. So just note that you don't have to be careful with your case when working with SQL queries. So going back over to our application, I'm going to quickly save that onto my network drive so that I have the ability to work with it. And saving early gives me the ability to see the color coding of a specific to Java. So I will go into this semester examples, and we will call it cities of the world.java. All right, now I see the color coding appropriate to a Java application. So I am going to create a few strings that I'm going to use within the application. The reason I'm creating these constant strings is they give me a place at the top of my program if changes were to come in the future that I needed to change, say, what SQL RDBMS driver I needed. If, let's say, we went from MySQL to the Enterprise Oracle product, or to Microsoft's SQL Server product, or something like that, we only have to change the driver at the very top of the application. So I just make these constants at the top in order to work with them lower in the application. You'll notice we've with the URL, we're familiar typically with HTTP and HTTPS as our protocols within URLs. We have access to a large number of protocols within the Universal Resource Locator context. In this case, we're doing JDBC against MySQL. And we're going to be connecting to specifically the database on my local computer. And so that's localhost, and the database we're connecting to is world. And I'm going to add this use SSL equals false. SSL, or secure sockets layer, is something that we use a lot in the internet. That's where the S in HTTPS comes from. And that secure sockets layer is a way to encrypt data over the wire. For simplicity's sake, we're not going to delve into that in this example or in this lecture. But when we're working with a program locally on the same hard drive as the database itself, SSL doesn't give us any help anyway, because we're not actually working with the data over the wire. We're going to set up the username that we're going to access the database with. Typically, your database administrator will create a service account that is associated with your application and unique to it, so that for security reasons, if for any reason they needed to remove access, they're only removing access for your application, or if in the event you need to change the password, it's only affecting just the application that is accessing the database. I set up this particular user and password pair when I installed MySQL on my computer. You can do similar when you create your when you download and install MySQL on your own computer. If you create a different username or password, you will have to trade out what's listed here in order for your application to work. Because this is just a command line application, we'll go back to our old friend public static void main string array args. And now we're going to create the connection string that I mentioned to you before. I'm just going to call it CONN, and I'm going to initialize it to null, make it empty. The reason I'm doing that now is we're going to, when we go to create our connection string, we're going to have to do that within a try-catch sequence, because we have to make sure the database is there, that it's reachable, that it's that the table we're referring to exists, and that the user that we're attaching with has access and has rights to the table we're looking for. There's a lot of variables of things that can go wrong when we go to connect to a database, particularly when that database is remote. So we're just going to create the objects at the global level, and then we're going to work with them in a try-catch sequence down here. Now these objects that we're working with, the connection string, the command object, and the results set, all of which we talked about at the beginning of the lecture, are available inside of the java.sql API library. So once we've imported all of the classes within the SQL API, we have access to all of those object types. So what we're going to do is we're going to use the class, which is an objectified version of the idea of a class inside of Java, and the class generally gives us access to the Java runtime environment that we work with. So what we're going to do is we're going to use the static method for name to register the driver that we made as a constant above. So what we're doing here is the driver called com.mysql.jdbc.driver is now registered in the namespace within the Java runtime environment. That's the first thing that'll occur when this application runs. Now we'll set up our connection string. So for the connection string, we're going to use the driver manager class and use its get connection static method, and we're going to connect using the URL to the database server and table we want, and we're going to access that with the user and password we defined above. Now, just to make sure that we kind of all understand these first two operations, let's go take a look inside of the Java documentation, API documentation for these items. If we go to the useful links page and then go to our Java 8 API documentation, we can find the java.sql API library, and we see a number of interfaces and classes here. One of those is driver manager. The driver manager allows us to work with the registered database driver that we registered in the line above. So when we registered com.mysql.jdbc.driver with the runtime environment, the driver manager is a class that allows us to interface with that. And you'll see this is one of those classes where all of our methods are static. We don't create driver manager objects. We simply do operations against the registered driver, the registered SQL driver, such as getting a connection. And the version we're using is the one that allows us to supply a URL, a user, and a password. There are other versions, like one where we don't have to supply the user and password. Perhaps we're going to ask the user to supply those, and then we'll operate against the database in that way. Or perhaps it's a database set up with no username or password, something like that. And you'll notice it says it's attempting it because, as I've said before, there are some things that can get in our way and cause problems with accessing the database. If for some reason there's an access error or the supplied URL is null, we'll get a SQL exception. essentially what's going on there is if we can't reach the database, if we're refused connection to the database or the table, um, anything like that, will receive a SQL exception. There's also can be login timeouts when there may be interference over the network or the server's having difficulty responding to your request, something like that. So these exceptions can be thrown, and we'll handle those um, in our catches below. So going back to the code itself, let's now create our our command object to be able to send particular commands to our database. So for now, let's do let's create a statement against our database connection. And this is typical in all of our programming languages. The statement is going to be created, the command is going to be created against the specific database connection. It's not uncommon for us to work with multiple databases simultaneously. We may have a connection to one database where we're going to read data, and we may do manipulations or changes to that data and then store it into a table in a different database. So we want our commands to be associated with a specific command string so we know which set of tables we're operating against. So now we'll create just a standard string object that I will call SQL, and that's going to contain our actual SQL code. We're going to do a simple command this time. Select city.name from city. We'll just select the names of every city from the city table. We're going to keep this simple so that we can build on this, learn a little bit of SQL coding along with our Java coding, so that in the end we pick up some extra skills and allows us to play a little bit until we get an opportunity to take a more advanced class and learn more about writing transactional SQL statements. So we also want to set up a record set, since we know this is going to return multiple rows. And the record set is specifically tied to the query itself. So just as we created a database connection to a specific database, and then we created a statement against that specific connection, and we now want to connect. We want to execute the query against the specific command. So the command is attached to the database connection, and then we're telling the command to execute the query written in the particular query string that we wrote on the line above. Now, just for simplicity's sake, so we can see what that looks like, we're going to take the record set, and while there is still data, similar to when we went against a scanner inside of a text file, We can check if there is a next item within the record set. If there isn't, this will be false. It'll drop right out of the loop. So that's why we use a precondition loop. If the record set's empty, none of these operations will run, and will just drop out. So what we're going to do is we are going to set up a string, and we're going to call it city name, and we're going to do the get string city dot name from the record set. When we work with record sets, we want to get the data in a particular data type. If we go over and look at the results set, we can see that we have the ability to get data in a variety of data types that translate from the relational databases type into the type that we're working with here. Again, don't get too hung up on the data types that are available to us. You'll notice that a lot of them do correspond to things we're used to, like ints and longs and strings. The ones you don't understand, again, I would refer you to a course on SQL to learn more about those data types. But what you'll see is when we get a particular thing, again, as a string here, what we can do is use the column label in order to say, give me the data in that particular column for the row I'm on. And remember, we're looping through the record set. So what I'm saying is, in the city table, give me the data in the name column. You'll notice the dot operator, very similar to when we talk about objects and fields within that object. The same notation is used against the database. City is the table, name is the column. Now, in this case, there's nothing else for me to get. The only column being returned in this record set is the name column. So by doing that, we know that's all we're going to get. But I'm going to expand on this program in a few minutes, and at that time, it'll be valuable to be able to refer to our columns specifically by name. And then we'll just go ahead and we'll do a print to the screen. And we'll do the city name, which is going to be whatever came out of the record set, and we'll just do it. We'll just leave it at that. One of the things that's important when we're working with these database objects is to close them when we're done. We're working with access against specific objects. Just like with files, we want to make sure we close those when we've completed them. So we can close all three objects we've created here at the end. And now we can create our catch statements. If you remember, we could have a SQL exception, SE, And in that case, we're just going to go ahead and print out whatever message is associated with it. And that will take care of both the regular SQL exception and the SQL timeout exception, because if you notice, when we go over here and look at the SQL timeout exception, you'll see that that SQL timeout exception is a subclass of the SQL exception. And when you looked at exceptions at the end or near the end of your CIT 130 class, or in the beginning of this class, you learned that if we catch the superclass, we we catch the subclasses as well. If you wanted to do something more specific with the SQL timeout error, SQL timeout exception, I believe that is correct. SQL timeout exception, the O is lowercase. And I gotta spell it correctly. We do have to do that above the SQL exception, because if it's afterwards, the SQL timeout exception will be handled by the superclass. When we want to handle subclass exceptions, we have to put those before the superclass exceptions so that they're handled before the other catch statement is gotten. So in this case, I may want to say, I may want to send a specific message, say something like, the database is not responding. Something like that. We can have that as a different, more specific element here. So let's go ahead and save our work, and let's take a look at what happens. Teaching. This is the fall of 2018. And we're going to go into the example subdirectory. We're going to do Java C cities of the world.java. As long as we didn't make any mistakes. I forgot to give a local name to the exception. It'll be STE for SQL timeout exception, and we will recompile, and we should be all set. Oh, the class not found exception that goes with the for name was not caught. That's if the driver is not located on the hard drive of your, of the application, which can happen particularly if for some reason the application is shared across computers without the JDBC driver in the jar file. So I'm going to add an additional catch here. I'm going to go with the root level exception, because I know, because I've already installed that driver on this computer, that I'm going to be fine. But I'm going to, because that is a checked exception, it won't compile without me doing something with it. Something that some programmers will do for a catch-all for, say, checked exceptions that they know aren't going to happen, or just to be extra careful, you can add a catch exception E. Again, you would want that at the end, because we already know that the the SQL timeout exception is a subclass of SQL exception, which is a subclass of exception. Again, you go from narrowest to widest when you want to handle the more specific differently than the more general. If you have any challenges with that, feel free to email me separately or contact me offline, and I can help explain how we catch exceptions when they're subclasses of other exceptions we're working with. We'll save it again, and I think this time we should compile successfully. And now let's run the application and see what happens. We get a list of every city in this particular database. It's a very large set. And you'll notice there's not particularly any order here. By default, it will dump these out in order of the primary key. So what you're seeing here is just the order in which these were added to the database by whoever populated that data in there. There are ways to mass populate data. If let's say you got a data set from somewhere else in a CSV file, there are ways to pull that into your relational database in a mass operation so that you don't have to type in all of those things if you're receiving them from somewhere else. Now let's go and do something slightly more complex. Let's take a look at if we wanted to know what country was associated with each of these cities. We can go and do country dot name, but instead of looking at the databases using commas to separate the databases we're attaching, we need to talk about how we are linking or utilizing the relationships between these tables. We need to be specific with that. We generally use a command called join to take one of the tables in our relationship and join it to the other one. So when we take city name and country name from city, we need to join to country, and we have to pick what we're going to join on. Generally, what you're going to do is join on the foreign key. So what we'll do is we'll do the join where city dot country code, and if you look back in our columns, you'll see there is a country code associated with each city equal to country dot code. And again, you'll notice within the database that the columns of the country includes a code, which is the primary key there. And in this case, rather than an auto increment, country codes are three-character strings that they've just decided what is the unique three-character code for every country in the world. If a new country has to be added, that requires the person working with the data to make sure that what they're inserting isn't reusing one that's already in there. The good news is there will be an error produced by the command if you try to insert a piece of data with a primary key that's equal to another row. That by designating it as a primary key, the database maintains the integrity of the data. It forces that on you. So now what I'm simply going to do is, instead of just getting all the city names, let's also get country names to go along with those. And we'll make a string for that. And this shows us how we can work with multiple columns. Country dot name. Work with multiple columns in the rows that are returned in our record set. So what I'm going to do here is I'm going to add like a little comma and add in the country name so that we'll see that. We don't have to update anything else. All we're doing here is changing what's in the command the command string. So it's simple stuff. It should compile just fine unless I misspelled something, and then when we run we'll get a similar looking result, but this time it's going to have the country associated with each city in the return record set. And one of the things we'll notice is that it's kind of working country by country here. So when they entered in the cities, they at least appeared to have done it by country. So now we're seeing the results of every city and what country it's associated with. And we could add in particular where clauses, just like we did when I did the raw example inside of the MySQL workbench. And I could say that we're going to check where city.district equals Nevada. Now, one of the things that I realize as I'm working through all of this that I may not have mentioned up to this point is that in SQL, the designator for a string is the single quote, not the double quote. The double quote's what we're used to in Java, among a lot of other languages. In SQL, we put all of our strings inside of single quotes. So that's important to note. Let's save it. We'll compile it again, and now we'll get a much smaller record set where it's going to just show us the cities that are associated with Las Vegas. Now, one of the things you'll notice, and this is in many ways because of I've used this database previously, is in this particular, in the state my database is in right now, there are two North Las Vegases in the United States. Two rows have the same sets of data for what I've shown, but if we go over here and look specifically at the data we have for essentially the same query, what you'll notice about the two North Las Vegases is their IDs are different. This is the value of the primary key. The primary key shows how these two elements are different. Now, someone who was auditing our data might notice that, oh, someone who was doing data entry accidentally entered the same city in twice. What they would most likely do is go in, find out which one has the correct population, and remove the other row. And what would happen by removing one of those rows is that would leave a gap in the set of incremented IDs for the life of the database. It would not reuse that ID. So let's look at adding a row. And this will, one of the things that this will also help with is it's going to give us the ability to see how we can reuse the same command for for multiple operations. So what I'm going to do is I'm going to move that one down, and I'm going to create an insert statement here. And what we're going to do is we're going to insert into city. We choose which table we're going to insert into, and we say values. And then we'll put in parentheses what values we want in this particular insert statement. So if we go back to SQL, to our workbench, and we look at the city, we see that we have the ID, the name, the country code, the district, and the population. So in this case, we know that our district's Nevada, our country code is USA. We're going to add, let's add the city of Mesquite. And for the fun of accuracy, let's go ahead and look up the population of Mesquite, Nevada, and we see 18,541. I'm going to just write that down before I forget. And what we need to do is put in order, these have to be in order, the data that we're putting in there. So we had the name, I think it was then country code, I think it was then district, and then population. Let's verify. Name, country code, district, population, name, country code. Okay. In some database management systems, this would work. Microsoft SQL Server is one where this would work. In MySQL, when you have the auto increment column, we have to put a placeholder in for it. Microsoft SQL understands it implicitly that it's there. But when it's an auto increment, obviously we can't give it a value because the value is auto assigned. So what we'll do is we will send null as a placeholder for the ID, and then the database will assign an ID to it automatically. So now that I have a command string for the insert, in this case, we don't need a record set. The insert isn't going to return anything. So what we're going to do is we're going to do a command dot execute. It's not execute query. Execute query executes query strings that return data. When we're querying the database for some kind of result set. So here we're going to just use the simple execute, but it'll be against the same string. A string is a string. So we can use the same command for executing inserts as we use for executing selects, and we can reuse both the command and the string when we do this operation. So what's going to happen now is we're going to insert Mesquite, Nevada, and then select all the data back. So where before we got Las Vegas, Reno, Henderson, Paradise, North Las Vegas, Sunrise Manor, Boulder City, and North Las Vegas, there will be an additional row here that for Mesquite. So let's save our data. Our application. Let's recompile. And you'll see Mesquite is now a record inside this database. So what we have successfully done here is we have created a new row in the database, and then when we selected that data, we see the results. So what you'll find is there's limitless possibility here, and the application development is fairly concise and fairly straightforward. One of the things that's great about working with databases is they're not very difficult to work with. One of the reasons for the enduring staying power of relational databases is the simplicity with which we can work with very complex data sets in with a very small set of operations, and we can do it fairly simply. Just as a quick review, we have a driver associated with the database system we're working against. We need to have a URL or some pointer to the server itself. Generally, we need a username and password to securely access that data. And then all we have to do is register the driver with the runtime environment, use that driver to connect to the specific database with the username and password. Then we create a command object against that connection. Then we can create strings of SQL commands that we then call or execute against the command object which is attached to the database connection. We use the execute API call when it's some sort of insert, update, or delete operation. We use the execute query API call when we're doing a select and getting a record set back. And that record set is simply just a data structure that we can loop through just like we would an array or a data file or anything else. I'm simply taking each field that we've requested, the name of the city, the name of the country, and just printed them to the screen just to show you. And of course, it's always important to close those objects when we're done. And then just did some very simple exception handling, keeping it real simple here because this is all self-contained. Any errors that are going to occur are ones that I made as the developer. They're not going to be user-based. So I went real simple, but it gave us a real concrete example of exception handling in hierarchy. If you haven't seen that before, since SQL timeout exceptions are a subclass of SQL exceptions, which are a subclass of exceptions, we can handle, if we, in theory, if we get rid of all of these, we would handle all of the exceptions, but in a very general way, where it would just do a stack trace, like if the program crashed. So maybe we want to be more specific and do a get message against our SQL exceptions. So we might just have the latter two. But if we wanted to do something even more specific, it was a timeout, like give a very specific message that we've pre-chosen, then that one would come first. So when there's subclasses that we want to handle differently from a superclass of any particular exception, we put the narrowest one at the top. Otherwise, it will use the more general one. I hope that this has been interesting and not too complicated for you. And I hope that you take the time to download MySQL and the driver associated with it and play around with this yourself. And again, I strongly encourage all students to take a SQL class. You can learn a really, really wide variety of operations, commands, queries for databases. You can learn how to properly design your databases, import data into them, and work with that data so that in the end you're efficiently working with large data sets, which is something that you're going to see if you go on to program professionally, which I would assume anyone in an advanced Java class would want to do. Take care and enjoy programming.